Welcome back, guys. Welcome to the channel. Today we are going to discuss about the OSPF protocol. And this OSPF protocol is what Open Shortest Path First protocol. Okay. So let's start with the part one because this OSPF protocol is very huge protocol. So we have divided this lecture into two parts, theoretical portion. So very first, guys, if you go with any OSPF protocol version of OSPF, so we need to understand what are the reasons that OSPF came across. Okay, so there are some drawbacks of earlier versions, earlier protocols. Like if you go with the, let's say, first topic is why there is a OSPF required. So there are so many problems of distance vector routing protocol, guys. So as you know, the category of distance vector routing protocol, which is a dynamic routing protocol also, where an example of distance vector is what the RIP, that is routing information protocol. And this RIP protocol is very good in small network only because having only 15 hops of hop count maximum 0 to 15 hop count is available, so it is going to be used for only small networks. Then there is also count to infinity problem. If let's say any route breaks, then definitely there will be no available path, external path available, so count to infinity problem also there, looping problem also there. Then slow convergence is there because of complete table is there, and that is going to be very slow because immediately they are not exchange their tables. After every 30 seconds they exchange the tables, so convergence will be is slow. Then large update packets is also drawback. Then slow response to topological changes. So these are the drawbacks of the RIP protocols. So in order to overcome this drawback, what we have another mechanism, and that mechanism is what the OSPF. Then let's discuss what do you mean by OSPF protocol. So OSPF is an open standard protocol anyone can use, as like the EIGRP. EIGRP, this is what the Cisco proprietary router, or let's say what we can say the routing protocol. But here OSPF is what the open source. Anyone can use for any network, no matter what kind of service provider it is, no matter what kind of organization it is. So it is available for all open standard. Then OSPF protocol is intra-domain routing protocol. As we know the category inter-domain and intra-domain. In intra-domain, what we have RIP also there, in the OSPF also there. In inter-domain, what we have a BGP protocol. This category we have discussed earlier. So it is a kind of intra-domain routing protocol. A protocol based on the link state routing. Again, we have what the distance vector routing protocol, link state routing protocol, and the path vector routing protocol. Here, there is a second category is what the link state routing protocol, where the link state packets are going to be sent. Then OSPF is a link state routing protocol that updates routing table only when the network changes occurs, rather than at the predefined time. As we know, guys, there is a 30-second time interval in RIP. After every 30 seconds, the RIP sends the updated packet. But here, OSPF protocols not taking the predefined time. It's like whenever the changes occur in the network, that time the updates are going to be sent. It is kind of, let's say, trigger update or maybe incremental update, we can say. This is what very good point. To handle the routing efficiently and in timely manner, OSPF divides the area, divides the autonomous system into different areas. We'll discuss this in different slides. It supports the classless routing. OSPF supports classless routing. It supports also VLSM, CIDR, manual route summarization, equal cost load balancing. These are the features, guys. Okay. Then administrative distance of the OSPF protocol is what 110, as like RIP, what we have 120. Here 110 is there. So slower in administrative distance will be effective one, and it uses the multicast address for routing updates is what 224.0.0.5 and 224.0.0.6. So these are the basic points about the OSPF protocol, and there are version 1, version 2s are available. OSPF version 2 is very much popular nowadays. Then let's discuss the second term, that was the autonomous system. So as we know, an area is a collection of networks. Autonomous system is an area of collection of network, host, and routers, all contained within a same autonomous system. If you go with this diagram, guys, this is what the autonomous system, where the areas, the routers, and the devices are connected. An autonomous system is a set of routing prefix for the connected internet protocol under the control of one or more network operator on behalf of single administrative entity or domain, which provide the general clearly defined internet routing policies. And this autonomous system is governed by one system administrator policies. There will be a what we can say the governing rules are there. So that is what responsible to handle all these kind of steps over there, routing policies, etc. Whatever they need to do. So this is going to be done by that particular on behalf of that single administrative entities. Then autonomous system can be divided into many areas. Here, if you see, guys, here there is a backbone zero area is there. Zero area zero is backbone area. Here area one is there, and here area two is there. And what is the purpose to divide this area? The goal to having the area is what localize the network as follows. And divide localization is going to be available, because if we divide these areas into different this autonomous system into different area, so maintenance will be good, routing table size will be reduced, and traffic will be reduced also. Okay, so congestion will also be reduced. So it is going to be, moreover, autonomous system is divided into areas only to handle the traffic efficiently. Then there are routers available in this particular autonomous system. The very first router is the area border router. Guys, if you see, let's take this. If you see this area border router, at the time of OSPF multi-areas configuration, we have to separate video. That time this area border router plays very important role. What is the purpose? It located near the border between two and one or more OSPF areas. So here located area 1 and area in between the area 1 and area 0. It is used to establish the connection between the backbone network and the OSPF areas. So backbone network is what, this area 0 and this area new area. It stores and maintains separate routing information and routing tables regarding the backbone and the topologies of area. In our video, that is OSPF multipath multi area video, we have shown this area differently, and we have set it this what we can say the ABR. We have set it this ABR, and we have shown there is a command, guys, show IP OSPF neighbors and the database. Here there is a this information has been shown in second video. The backbone routers, the second router, backbone router, a router that is used to connect autonomous system in the large internet network such as internet. So this is what the backbone router. This is what the backbone router, guys. Now, autonomous system boundary router. If one autonomous systems wanted to communicate with others, so that's supposed to be have autonomous system, one router. So here, in between these two autonomous system, there is a autonomous system boundary router is also available. This plays at the time of if more than one autonomous system connected that time. Then internal router, these are the internal routers are available, guys. A router that has the OSPF neighbor relationship only with the devices in the same area. So if I have here let's say here, these are the routers are connected via some DC mechanisms, and then they become the neighbor with the help of that hello packets. Okay, so this is what the concept of autonomous system. So moreover, if you see that OSPF protocol is what very large used in large network. So for that handling the large network, that network is divided into a number of areas. Okay. Then there are concept of the OSPF tables. Right? There are actually three tables available: the neighbor table, topological table, and routing table. In earlier protocol, we have discussed only one table, and that table is what the routing table. But if you go with this OSPF protocol, there is a neighbor table, and what it maintained, it contained all discovered OSPF neighbors with whom routing information will be interchanged. And it means what it shows it store the information about the OSPF neighbor. Who is neighbor? Let's say if I have a R1 over here, if I have, let's say, R2 here. So who is my neighbor? Okay, the neighbor information is going to be stored in the neighbor table to find to build their adjacency. In topological table contains the entire roadmap of the network with all the available OSPF routes and calculate best and alternative path. So best and alternative path it is available. Also, it stores the topological structure of the network. So in a topological table, it's available of what one best path also entry is there, and alternative path also entry is there. If best path is going to get collapsed, that time alternative path will become the best path. Then the third type table is what the routing table. It contains the current working best path that will be used for forwarding the data traffic between the neighbor. It is hold the current best path. On the basis of that, the traffic is moving. Okay, so these are the tables, and that's why if any best path let's say got break, so alternative path is available. So computation time is again very less. That is what the benefit of this topological table. Then there are basic terms, guys. Very first basic term is the router ID. It is the highest active IP address present at the router. First, highest loopback address is considered. If no loopback address is configured, then highest active IP address on the interface of the router is considered. So there are two IDs will be there. So router ID will be what? The highest IP address. So very first we have a loopback address, and then if not loopback address set, then highest IP address on that interface is going to be considered. Then router priority, it is the 8-bit value assigned to router operating OSPF used to elect DR and BDR, that is designated router and backup designated router in the broadcast network. For election purpose is going to be used. Generally, we have shown the priorities. What is it? Designated router, guys. It is elected to minimize the number of adjacency forms, and DR is elected in the broadcast network to which all the other routers share their database, other database. In the broadcast network, router request for updates to DR, and DR will respond to that particular request with the update. Here we have some message packets are available, requesting for some missing information and then giving that information. So that task will be handled by this designated router. We can say designated router is what the whole and soul, which send the information, complete information to the others. And what happen if this get failed? So what we have backup designated router. Let's say DBR is backup to the DR. In broadcast network, when DR goes down, the DBR become BDR become the DR and perform the same perform the same task, guys. Then how this election takes place? There are some rules. So election takes place in the broadcast network and the multi-area network. The rule number one: router having the highest routing priority, router priority will elect as a DR. So which one have the highest priority will be elected as a DR. And rule two: if there is a tie in the router priority, then highest router ID will be considered, and first highest loopback address is considered. If no loopback address is set, then highest active IP address on that interface is going to be considered. So ultimately, we have to elect the DR on the basis of some rules, and rules are what? Priority. If not priority, then loopback. If not loopback, then what we can have a highest IP address on that interface. So these are the basic terms of about the OSPF tables and the basic term, guys. Then discuss what are the links available, because OSPF protocol is going to be used in a very large network. So there's supposed to be a connection between the every routers, and there are supposed to be different types of links. Okay. So what is the link? The connection between the two routers, two nodes, is what the link for the communication. So this terminology is divided into 4 types. There is a point-to-point link, guys. The point-to-point link connected two routers without any other host. So here router 1 and router A and router B, there is no any host available. So this is what the point-to-point. In other words, the purpose of this link is to just to connect two routers together. And best example of this is what telephone lines. When we dial the any telephone number, so in between our phone and the telephone others phone, there is no any other numbers are dialed. Okay, so only two entities are going to be exchanging their thoughts towards them. So this is what the point-to-point, one-to-one we can say. Again, there is a second type is what transient link. Transient link is a network with the several routes attached to it. The data can enter through any of the route and leave through any of the route. So there are multiple paths are available. All the LANs and some WANs with 2 or more routers are of these types. In this case, each router has many neighbors. If you go with this router A, so here 3 neighbors are available: B, C, and D. Many neighbors are available. These are neither efficient and not realistic. How? It is not efficient because each router needs to advertise the neighborhood to 3 other routers. So whatever the connected routers, so here there are 3 routers, so they need to advertise their information to 3 neighbors. Or if we consider this topology, so minimum 15 advertisements are required. Okay, and it is not realistic because there is no single network link between any pair of routers. But moreover, we can say this structure is very good for the backup purpose, guys. If there is one route failed, the alternative is also available. There is a third link is what? Stub link. In this network, OSPF network, that is connected to only one router. There is only one router, and the one router is only responsible that data packets enter that network through this single router and leave this single router. It means what? There is only one router, and one router is responsible to receive the input and throw the output on the outbound port. So this is what the stub link. Then there is a virtual links also there. When the link between the two routers broken, then administrator may create the virtual link between them using the larger path that probably goes through the several routes. So virtual link is not available, guys. Virtual link is only established when the what we can say, the path has been collapsed between the two routes, then only it is going to be created. And but the reason is to select the larger path only in the future purpose, that if that also got failed, so it is going to be alternative paths also available. So virtual path is not available physically. It's only created after that particular link failure. Then there is another concept, and that concept is, let's say, OSPF common header format. So here we have the header format, guys, in front of us. There are different fields are available. On the basis of this, the OSPF is going to be what? The very first is version. So version field is 8-bit field, is defined the version of the OSPF protocol. Currently version is 2 is using. Version 1 is obsolete, and version 2 is now currently we are using. Then there is a second term is what the type. There are 5 types of different messages are available, guys. So this is also 8-bit field, and it indicates the packet, like 3 of 5 packets, 3 or 5 packets are there, and value will be 1 to 5, like hello packet, what we can say, the database description packet, what we have again, the request packet, then acknowledgement packet, then the update packet. These are we have separate video on that particular packet, so do watch that video also. Then message length. This is a 16-bit field, define the length of the total message, including the header also. Then source router ID, that is IP address, it is 32-bit because we are using on the IP version 4. So 32-bit, define the address of the router that sends the packet, who's sending the packet, that address is going to be available over here. Then area identification, as we know, guys, that the area autonomous system is divided into different areas. So here, this is 32-bit field, define the area within which the routing going to be takes place. So identification of area is must. So while configuration, we generally need to give the area 0, area 1, area 2, etc., etc. Then there is a checksum. This field is used for the error detection on the entire packet, excluding the authentication type and the authentication data field. So this is what the error detection and correction purpose. Then authentication type, this is 16-bit field, define the authentication protocol used in this area, which protocol is going to be used as like a through which protocol is going to be, let's say, message digest, MD5, etc. At this time, 2 types of authentications are defined: 0 for none and 1 for the password. So password we can set for while the what we can say, the adjacency form. Okay, then authentication, it is 64-bit field in the actual value of the authentication data. The authentication type is 0, and this field is filled with 0. If the type is 1, then field carries the 8-bit character password. So these are the terms we have discussed, guys, about the OSPF protocol. And this, what we have discussed, the why there is OSPF protocol is required, what is OSPF protocol, then what mean by the autonomous system, and then we'll discuss what are the links are available. Then we have discussed the tables are available, basic terms, and lastly we have discussed about the header format. We have the second video for the OSPF protocol because OSPF protocol is very large protocol. We have divided this lecture into 2 parts, part 1 and part 2. So this is what the part 1. Please do watch that part 2 also. Thank you so much.